Example 1.5. A charged metallic sphere A is suspended by a nylon thread. Yes, A is suspended by a nylon thread. Another charged metallic sphere B held by an insulating handle. Yes, no direct contact. By using the insulating handle B is held, which is also charged metal close to A such that the distance between their centers is 10 centimeter. The separation between these two centers is 10 centimeter. Now, the resulting repulsion of A is noted. So, spheres A and B are touched by uncharged spheres C and D respectively as shown in the figure. C and D then are removed and B is brought close to A at a distance of 5 centimeter as shown in the figure. What is the expected repulsion of A on the basis of Coulomb's law? We'll realize the question first. What is given, we'll see. Initial charges on spheres are given. Let us take charge on A is equal to QA, charge on B is QB, initial distance is 10 centimeter. By using Coulomb's law, F equal to K Q1 Q2 by R square. Separation 10 centimeter multiplied by 10 to the power minus 2, that is 10 to the power minus 1 meter. So square of this becomes 10 to the power minus 2. So K Q1 Q2 into 10 to the power 2. Okay. Now, what happens when touched with identical uncharged spheres? It's a very important point is to be noted. When a charged sphere comes in contact with another identical uncharged spheres, charges are equally shared. Therefore, charge on A becomes QA by 2, charge on B becomes QB by 2. Okay. New separation is given as 5 centimeter. Now, we have to find the new repulsion, right? Okay, force is equal to same formula, K, charge on A, charge on B by separation. Charge on A, QA by 2. Charge on B, QB by 2. Separation also becomes half. That is, if original separation 10, now it becomes 5. 5 into the power minus 2 whole square. If you simplify this, you are getting K, QA, QB by 10 to the power minus 2. Now we'll compare this with the original force. What is your conclusion? Original force and this force both are same. Both we are getting it as K, QA, QB 10 to the power 2. That is force equal F1 equal to F2. Example 1.6. Consider three charges Q1, Q2, Q3, each equal to Q at the vertices of an equilateral triangle of side equal to L. What is the force on the charge Q, which is kept at the placed at the centroid of the triangle as shown? All are having same sign. Okay. First, we'll try to realize the question. What is given here? The charges which are kept on the vertex Q1, Q2, Q3, all three are equal. Then, second thing, there is an equilateral triangle. The fourth charge, capital Q, that is kept at the centroid. Okay. Now, this is the centroid, right? Yes. Centroid divides the median in the ratio 2:1. This is centroid. How it divides this median? 2:1. Suppose this is equal to 2, this is equal to 1. So 2:1 ratio. It is dividing at the ratio 2:1. Okay. Now we have to find the length of this median. This side length is given as L and it is bisector. So this angle is 30, this angle also 30. So this is L, this is 30. So which component will act here? Cos component. Therefore, this line, that is AD equal to L cos theta. Cos theta value equal to 30. So L into cos 30 value root 3 by 2. So AD length equal to root 3 by 2 into L. Now, what is AQ? AO. What is AO length? Distance from centroid to vertex. Since Centroid divides the median into 2:1. Now, if it is 2, this is 1. So, total 2:1 matlab 3. 2 out of 3 is this portion, right? 2 by 3 of median, that is 2 by 3 into median is root 3 L by 2, that is you are getting root 3 by 3 or 1 by root 3 into L. This is the value of R, that is here to here distance. A to O distance equal to L by root 3. Now, force due to one charge using Coulomb's law. Now, I'll take the selected point is O. Any one, I will take charge Q1. What is the force here? Q1 into Q, that is product of charges, separation equal to R, that R value we found out as L by root 3. So now we'll multiply by L by root 3. So force become K, Q into Q, L by root 3 whole square, K, Q, Q, L square by 3 or 3K, Q, Q by L square. This is the force between A and O. Similarly, we'll go for force between B and O, force between C and O. Okay, before going that we will complete. Now this force we calculated. 3 forces act on Q, each along line joining the centroid to vertices. Matlab, we got this force now. This force is opposite. Now similarly, this one will be opposing in this direction. Force between C and Q, that is also in this direction. These all are opposing forces. Now, first, we will find out the resultant of F1 and F2. In the equilateral triangle, when two forces are equal, angle between them is 120 degree, then the resultant remains same as that force. We can prove this by using triangle law, or resultant force F equal to square root of F1 square plus F2 square plus 2F1 F2 cos theta. Here theta becomes 120. Therefore, if you simplify, when two forces are equal, angle is 120. The resultant becomes same as any one of the force. So now F1, F2 का resultant is F I will take. This is same as F1, but we already proved that F1, F2, F3 all are equal. So A two forces का resultant is upward and that is equal to FV, equal and opposite. Therefore, the net force becomes 0. Net force on charge Q becomes 0.